All right, so this is an example of a setup for the remote lab. What I have here is a long box that I'm using as an incline, and I'll be rolling objects down it. Obviously, you may not have a box that long sitting around. As long as whatever you're using is at least a couple of feet long, that is fine. Like 3 feet long would be ideal, which is even longer than that. Yeah, just try to get as long of an object that's flat that you can put on an incline to use as you can. Now, I have my Arduino with the motion sensor basically just sitting on top of the box. You can try to tape it down, but you will most likely need to adjust the angle quite a bit to find one that works. This is a little bit finicky, and you will be needing to take data repeatedly to try to get a run that actually works well. And you can see I have a piece of paper here to use as a shim if I need to angle this side to side, like the whole incline. And then I have a little piece of paper here that I'm using to try to adjust the angle of my Arduino motion sensor so that it records well. The idea is just that we're going to take different objects with different shapes and record their acceleration down the incline, as well as the angle of the incline, and compare how quickly they should theoretically accelerate with how quickly they experimentally accelerate. So I've got examples of the 4 different types of objects that we want to use. The candle that I have here is just a solid cylinder. I've got a roll of duct tape that doesn't have much on it. If it's got too much on it and it's really thick, it won't be as close to a, this is supposed to represent a hollow cylinder. You can also just use a can with both the top and bottom cut off, and that works fine. For the cylinder, this will work. A rolling pin may work. If you really can't find anything, a roll of toilet paper obviously is hollow at the very center, but the way the rotational inertia works, the parts at the center contribute less. So a large roll of toilet paper may work approximately as a cylinder. It won't be, the best object to use, but if you can't find anything else, that's something I'm sure most of you have a roll of toilet paper somewhere you can use for this. Then I've got a racquetball for my hollow sphere. You can also use a tennis ball. And then I've got a pool ball for my solid sphere. You can also use just like a foam stress ball. I've got like this foam stress ball over here. That would work as long as it's all the same material and it's solid all the way through. That's fine. So those will be the objects I'm using. As far as finding the angle, what you want to do is you want to mark 2 points that you're going to measure the height from. So I've already done that, but I've taken my meter stick, and this meter stick is actually 1 meter long. It doesn't have extra on the ends. And I've marked at 100 centimeters and at 0 centimeters. And so that length is along the hypotenuse. The ramp is angled, so that would be the hypotenuse of the angle that we want, or the hypotenuse of the triangle that we want to use. And then we can measure the height at the 2 points that we chose. And the difference in height will be the opposite of the angle that we want. So the sine of the angle will just be the difference in height over the length along the ramp. So you can determine the angle that way. So once you have the angle, you are going to just record data. I can't really easily record both the setup and my screen while I'm taking data. So I'll be cutting and showing you what the data taking process and analyzing process looks like from the computer. But as far as doing a run, all you're going to do is have the Arduino plugged in. Obviously, I don't have my computer over there because I'm recording on it, and have everything open. And I mean, I showed you in the last video how to record data with that, where you open the serial monitor and type start. So you're going to start recording while you're holding your object here, and then just release it once you've started recording. It will roll down. Like I said, this is fairly finicky. You may have to mess around with the angle of the incline and the angle of the sensor and all of that quite a bit. Also, the cylindrical objects tend to work better because they have, they're at least flat in one dimension. Since this is working based off of echoes, it works best for something that's got a large flat surface. The cylinders work all right because they're flat in one dimension, but the spheres will be extremely finicky. So do your best to get decent data. I'll show you what to do if you get data that cuts out some in a moment. But hopefully you should be able to get good data for whatever you're using for your hollow cylinder and your solid cylinder. I have been able to get good data for the spheres as well, but it's difficult and finicky. And so, it can be kind of tedious. So if you're really having trouble with it, I'll show you how to try your best to get something usable, even if the sensor cuts out some. But if you really can't do it, then just write in your lab report that you were unable, and maybe find other cylindrical objects you could use and see if you can get data with those or something, or you could change the angle. So as far as for remote students in class, the setups were a bit easier to use. So I had them record, two different angles and record multiple runs for each object. Since this is fairly finicky, I just want you to concentrate on getting one good value for the acceleration at a certain angle, just one angle for each object. And like I said, if you really can't get the spheres to work, that I understand because it is quite finicky. So now I'll show you how to, or what your data will look like and how to use a spreadsheet to analyze it.